Okay, I quickly want to go over a problem type from this week's homework, week 5. This is about linear approximation to estimate certain values. Like here in this problem, it's the square root of 102.9, right, near 100. So the near 100 tells us what the basis for our approximation is. So if you recall from the textbook, we can use the derivative to linearly approximate functions. So the general formula, I'll just type this here for convenience, so you don't have to do this when solving the problem. So it would be f of x, right? So we want to know f of x, and it's near. So you can use this approximate symbol here. You can also type just simply approx, and it should give you the same. So this is f of x is approximately f at the base point, right? So near 100 in this case, but let's do it generally first. So f of a plus the derivative of f at a times x minus a. So this is the general approximation or linear approximation formula as you find it in the book, for example. So let me just put this in here just for convenience. So the important thing for this problem is, of course, what is our f here, what is our a, and what is x, right? So that's not too hard in this problem, as it shouldn't be too hard for the problems in the homework, but let's look at it. So we have the square root function, so f of x should be square root of x, right? So, and we need to compute the derivative of that function. So let's do that first. So we need the derivative of square root of x. So let's write d over dx of sqrt of x. So that's using the power rule, you know, that's 1 over 2 times sqrt x. So 2 times square root of x in the denominator. Save our work, and now we can get to work for our problem here. We have all the necessary tools. Now what do we need to do? Well, which values do we need? We need the value of f of a, right? So that would be the value of this one, square root of x, at 100. So a is 100. So in this case, so we can use actually Gradarius to do this work for us. I mean, in this case, it's not really necessary for 100, but whenever you select an expression and you type evaluate, when you see functions evaluate at, and I want to evaluate that at 100 because that's our a, right? So we get 10. So I know that by heart, so I wouldn't really have to consult Gradarius on it. But the other thing is we need to evaluate f prime of a, right? So a is 100. So, and that's not that easy. I guess we could still do it without consulting Gradarius, but Gradarius can actually do this work for us. So we need to evaluate the derivative at 100, right here. So for that purpose, I'll just mark this expression again, type evaluate, functions evaluate at, and I want to evaluate that again at 100, and I get 1 over 20, right? That's the value if I plug in 100 here for x. Okay, now I'm pretty much done. I can now put everything together, right? Because we want to evaluate square root of 102.9, right? That's approximately that's approximately, right? So now we have all the tools. So f of a was 10 plus the derivative of f at a, that was 1/20th, right? And then I have here x minus a, right? So x here is where we actually want to estimate, right? So this is 102.9, right? 102.9, and then we subtract a, right, our base x here, and that would be 100, so we'd have minus 100, okay, and that's our formula now. Now what I can do is, and that's also Gradarius can do this for us, so if I select this and type decimal, right, DEC, then I want to have a nice decimal expression for this, so here this would be my approximation. So now I can select this and copy this to final answer, and I can check my answer, and everything looks good. Yeah, so that was a brief demonstration of how to do these linear approximation problems. Again, the most important part is identifying which function you're actually used to approximate this value. That's pretty straightforward in this case, right? And then identifying your base value, which is given when it says x near 100, so that's the base value. And then the x value where you actually want to approximate, it's the other value. And then you compute the derivative, evaluate the derivative at this value, right, at your base value here, and then put everything together. So the nice thing in Gradarius is that you can always use this evaluate function, right, to let the program do the computations for you, so you don't have to bother with it. Right. So here those computations were relatively simple, but there are much more complicated functions where you could do that. Right. So remember, always after you entered an expression, so you need to save your work before you can do this. So you cannot do an action while typing, but once you save an expression and you select it, you can apply these actions to it. Okay.